Hello everyone, myself Mohammad Musharraf from IRC Department 7th SEM. Today's topic is machine learning with Hadoop. So what is Hadoop? Hadoop is an open source framework for distributed storage and processing of large data sets. It uses a distributed file system (HDFS) to store data across multiple nodes, and the map reduces programming module to process and analyze the data in parallel. Hadoop is designed to scale horizontally, making it suitable for handling massive amount of data across a cluster of computers. Hadoop history timeline. Hadoop organized from a project called AppNet, an open source web search engine initiated by Tom Cutting and Mike Caffarella in 2002. The project was inspired by Google's MapReduce and Google File System papers. In 2006, Yahoo hired Tom Cutting and others involved in Nudge and started developing Hadoop as a sub-project of AppChallenge. The name Hadoop was inspired by Cutting's son's toy elephant. The key components, Hadoop Distributed File System (HDFS) and MapReduce were created to address the challenging of processing and storing large-scale data. After Hadoop is become a top level of project in 2008, and since then it has grown into a robust ecosystem with various sub-projects including Apcha, Hyperfuse and Big and more. Key attributes of Hadoop: distributed storage. Hadoop Distributed File System (HDFS) allows data to be distributed across multiple nodes in a cluster, providing fault tolerance and scalability. Distributed processing. Hadoop employs the MapReduce programming module, enabling process, parallel processing of data across more nodes in a cluster. Scalability. Hadoop is designed to scale horizontally, allowing organizations to add more nodes to the cluster as data volume and processing requirement grows. Fault tolerance. HDFS replicates data across multiple nodes, ensuring that if a node fails, data remains accessible from the nodes. Open source. Hadoop is an open source project under the Apple Software Foundation, fostering a collaborative development environment and allowing users to customize and extend the framework's flexibility. Hadoop can handle various types of data, including structured and unstructured data. It is not limited to a specific data format. Cost-effective storage. Hadoop's distributed storage module enables cost-effective storage of large volumes of data by using uh, commodity hardware. Ecosystem. Hadoop has a rich ecosystem with various tools and projects like Hypeak, Hybase that extend its capability for data processing, analysis, and management. Key principles of Hadoop. Distributed computing. Hadoop is built on the principle of distributed computing, distributing data and processing tasks across a cluster of interconnected nodes. Fault tolerance. Hadoop ensures fault tolerance to data replication in HDFS. If a node fails, data can be retrieved from replicates on the other nodes. Data replication. Hadoop replicates data across nodes to ensure durability and availability. The default replication factor is configurable. Open source. Hadoop follows the open source of module, ensuring collaboration, transparency, and community-driven development. Deal with failure. Hadoop is designed to handle failures gracefully through various mechanisms. Here's how Hadoop deals with failures. Data replication. Hadoop Distributed File System (HDFS) replicates data across multiple nodes in the cluster. By default, this replication ensures that if a node fails, the data can still be accessed from the other nodes where replaced and stored. Fault-tolerant computing. Hadoop's map-reduces programming module divides tasks into smaller subtasks, and these tasks can be executed in parallel on different nodes. If nodes fail during processing, the tasks are rerouted to healthy nodes for a continued execution. Fault-tolerant computing. Hadoop's map-reduces programming module divides tasks into smaller subtasks, and these tasks can be executed in parallel different nodes. If a node fails during processing, the tasks are rerouted to healthy nodes of continued execution. Task redundancy. Map-reduces tasks are often redundant. If a task fails, a redundant copy of a task is executed on another node to ensure that the job processes successfully. Task isolation. Each task is Hadoop runs in its own Java virtual machine (JVM), providing isolation. If a task creates it does not affect other tasks running on the same node. Abstract complexity. In Hadoop, abstract complexity primarily refers to the way frameworks abstracts and thus simplifies the complexities associated with the distributed computing and big data processing. Several aspects contribute to abstract complexity in Hadoop. Distributed storage (HDFS). Hadoop abstracts the increases of distributed storage through Hadoop Distributed File System (HDFS). Users interacts with HDFS as a unified file system, and the frameworks manage the distributed and replication of data across the cluster transparently. Map reduces the programming module. The map reduce programming module abstracts the complexity of a parallel processing on the distributed data. It allows user to focus on the defining the map and reduce the functions, while Hadoop handles the distributed execution and coordination of tasks across the cluster. Fault tolerance. Hadoop abstracts the complexity of handling nodes failure and data loss through mechanisms like data replication in HDFS and automatic rerouting of tasks in a case of failure during MapReduce uh, job execution. Scalability. Hadoop abstracts the challenging and association with the scaling by allowing organization of add more nodes to the cluster seamlessly. The framework handles the distributed up tasks and data across the expanded cluster. Summary. Hadoop is an open source framework designed for distributed storage and processing of large scale data across clusters of computers. Key components include the Hadoop Distributed File System (HDFS) or distributed storage and the map reducing programming module for parallel processing. Hadoop abstracts the complexities related to the distributed computing, offering cost tolerance, scalability, and a cost-effective solution. It has evolved into a robust ecosystem with tools like Hadoop and Yarn making the foundation tools for the organization dealing with the big data challenges.